Okay, guys, so this is what we took notes on last week, right? You guys have been working on assignment for a week already, right? Last week it was just a couple of questions. Earlier this week I gave you a couple more. So we're gonna it's kind of still related to this. It's just like a branch of this, okay? So do you remember here when we're trying to find the horizontal asymptote? And we have three scenarios: powers equal, bottom heavy, or top heavy, right? Top heavy is the only time we don't get a horizontal asymptote, right? That's why it says no horizontal asymptote. Well, that's true. There is not a horizontal asymptote, but there is a different kind of asymptote. Okay, it's not horizontal. Anytime we get a top heavy situation, we're gonna end up with this guy. So instead of a horizontal asymptote, we have what I call it slant. Some textbooks call it oblique, right? Tomato, tomato, same difference. Okay, it even has or slant in the parentheses. Okay, so if you are one of the people who requested a packet, great. All you have to do is kind of fill in the blanks. If you're a person who didn't request a packet, so I didn't make one for you, then go ahead and fill out your own separate notes. Make sure that you pause when you need to write stuff down, and then push play when you're ready to start copying stuff down. So I am going to explain what specifically oblique slash slant, well, slant, right? A slanted line. Okay, so that's basically what's happening here. So let's go ahead and fill out these blanks together. So when we have an oblique asymptote, okay, so let's go ahead and fill out these blanks. When the, actually, can't, okay, there you go. I can write better. So it says when the blank, when the degree, okay, of px, remember px is your numerator, okay, is 1 degree or more. Sorry, I'm not speaking as I'm writing. Sorry. Oops. That was the wrong place for degree. Exactly 1 more than the degree of qx. We have a slant or oblique asymptote. Okay, basically what that means is if you have top heavy. Okay, so if you have top heavy and your numerator degree is greater than your denominator degree, you're going to have a slanted line instead of a straight line. So you see here, I don't know if you guys can see this little dotted line. That little dotted line that's like diagonal. That's that slant asymptote that it's talking about. Okay, that's what it means. All right, so, and that's going to be some sort of linear line. Now, this next part tells us exactly how linear it is. You guys remember back in Algebra 1 when you learned about the equation y equals mx plus b, right? That's a linear line. It's linear, it's diagonal, okay? So basically what you're going to have to do is we're going to use 2 different types of division here. Either long or synthetic division. And that's going to be the equation of my slanted line. Also, I would notate it does say to ignore the remainder. Okay? So we're going to practice both methods. That way you know how to use either long or synthetic division to find the linear or slanted asymptote of these rational functions. Alright, so let's go ahead and start these examples here. Okay. Remember, I'm going to do I'm gonna do 2 of them with long division and 2 of them with synthetic division. That way you can see the difference between the two. Okay. Hold on. Okay. So my coefficient in front of x squared is 1. My coefficient in front of x is -1, and my constant is -14. Okay, I'm going to bring down that 1. -4 times. So what's happening here is I'm going to this guy gets multiplied. Okay, so -4 times 1 is -4. When I add those together, I get -5. And then again, it gets multiplied, kind of like when you divide normally, right? I know it looks kind of funky, but I'm going to multiply again. -4 times -5 is 20. And that's 6. Well, it does say to, where does it say? Here it is. It does say to ignore the remainder. Okay, so I don't really care about that -6. That would be my remainder. I just care about that 1 and then that -5. So that tells me my equation. Here's my invisible 1, x minus 5. That sets it up in y equals mx plus b format. This is going to be the equation of my slant asymptote or my oblique asymptote. Alright, we're going to use this method again for question 2, and then we're going to switch over to the next method. Okay, so 3. Okay, the coefficient in front of x squared is 3. The coefficient in front of x is -7. And then my constant, well, I don't have a constant, so that guy is 0. Okay, bring this guy straight down, and then we're going to get started. Okay, remember I'm going to take this 3 and I'm just going to multiply. So 3 times 3 is 9. When I add those up, -7 plus 9 is 2. So again, I'm just going to multiply, right? 2 times 3 is 6, which is my remainder that we're kind of ignoring. And then I have my equation, 3x and then a +2. That is the equation of my slanted asymptote. I'm just put SA for slant asymptote. Okay. Alright, these next 2 methods, oh, I don't know how well you can see that. I don't know why the printer's printing that way. But I'm going to rewrite it in case you can't really see it that well. That's a 3x plus 2. Okay, so this method we're actually going to use the other type of division. Okay, it's -11. Okay, so instead of that first method like question 1 and 2, we're going to go ahead and set it up using our second option. So I'm going to take that denominator. This one might be a little bit more familiar with how you normally divide. Okay, so I have numerator divided by denominator. Okay. Okay, so 6x squared divided by 3x. That's 2x. Right? Kind of like the way you would normally divide a number, right? 8 divided by 2, or sorry, 8 divided by 4 is 2, right? So it's kind of like that process that you already know how to do. It just looks really scary and really complicated because of all these x's and squaring and stuff, right? Okay, so let's keep going. So I'm going to take this and multiply, right? 2x times 3x is 6x squared. And then it gets done again, but to the 2. Okay, so 2x times 2 is 4. Okay, then we, just like we do when we regularly, what is it called, divide, we're kind of just doing the same thing again, alright? So these and actually both of these end up canceling out. I get 0x, and then this is just going to come down and be minus 11. And again, I don't really care about the remainder. 0x times, or 0x divided by 3, like that doesn't, that's just 0, right? So that's, I don't really need to put the 0 there then. I mean, I guess if you want to for like clarification purposes, but that's not gonna, it's not a number that's gonna make a difference. So my equation for this slant asymptote is just 2x, which still satisfies by equals mx plus b. Okay, m is 2, and b is that 0 that we were talking about that's like there. Okay. Alright, let's do another example. We're going to do more examples tomorrow in class, but so that way you at least kind of already have something to go off of. Just trying to rewrite these because they're kind of faded. This is x squared at the bottom, and then 2x minus 3. Okay, great. So now that I have those written out so we can see them a little better, let's start our division process. So x squared plus 2x minus 3, and then what's at the top? X cubed plus 3x squared. Now it's going to be a little bit beneficial here to actually continue, like keep going. So even though I don't have an x, I have an x here. So if I have an x there, it'd probably be best that I include it in my numerator, but I have 0x because that won't affect my equation. Same thing here, I have a constant, so it might be beneficial if I have a constant here as well. If I put plus 0, 0 is my constant, but it doesn't affect my equation. Okay, so I'm going to go ahead and start dividing. Right, because I'm doing this. X cubed divided by x squared. What is that? That's just x. Okay, so that's where I got that from. Alright, so this x is going to get multiplied. Okay, now again, but to the other term. So 2x times x is 2x squared. Okay, one more time, but to the negative 3. X times negative 3 is negative 3x. Alright, now we're going to start that subtraction process. Okay, 3x squared minus 2x is just invisible 1x. Okay, 0 minus minus 3 is 3x. Those two negatives make a positive, don't forget. And I'm going to bring down that plus 0. Okay, so now we're kind of like repeating this process like basically all over again. Okay, so I'm going to take this x squared right here and divide it by this x squared right there. X squared divided by x squared is just 1, right? Okay, so. Okay, this is just like my scratch work off to the side. Okay, so now I'm kind of repeating the same process. I'm going to take the 1 and multiply it by the x squared. Okay, I'm going to do it again, but multiply it to the 2x. And then I am going to do that again to just the negative 3. I mean, that's basically it. I don't really have to do the rest, like, because I know I'm going to have a remainder for sure. Okay, 3 minus 2 is 1x. 0 minus minus 3 is plus 3. This is my remainder, right? We know what remainders are, right? Like if we have 10 divided by 4, right? Let's say we have that. We have remainders, right? That would be 2, and then I have a remainder of 2. Do we remember when we learned basic division skills, right? So remainders are important, but in terms of just for the slant asymptote purposes, it does tell us to ignore the remainder. So I don't really care about that leftover piece. I just care about this answer, this top piece in the answer. Okay, so my equation for my slant asymptote is x plus 1. Okay, so tomorrow we are going to continue, but we're gonna obviously I'm gonna go a little bit slower, right? Because you'll be able to be there live during the meeting and ask me questions and things like that. But tomorrow we're gonna put it into action. Okay, so we're not only gonna find the slant asymptote, but we're gonna graph it and then continue graphing the rest of the equation, kind of like what we did when we last week, right? So we're gonna find all these things here that's gonna help us to graph the equation. Okay. All right, guys, have a great day. Bye.